So in today's class, we're going to discuss about adaptive streaming and so dynamic adaptive streaming over HTTP protocol. It is a hypertext transfer protocol, and some more detailed information about dynamic adaptive streaming. So over HTTP protocol, we're going to. So it is also called as a dash protocol. We're going to learn in today's class. So what is the adaptive streaming and multimedia? What is this exactly? Adaptive streaming means, so as you know that, so multimedia files. So multimedia files which are retrieved via HTTP GET methods. So HTTP, there is so many the methods which are able to, suppose if your GET is a fetching of, so that is audio and video files which are already stored in the multimedia servers. So assume that audio and video files which are already stored. So entire length of the videos, entire audio videos is already stored. It is from the streaming server. It is a either live streaming, or it is a stored videos able to access. So if it is to the subscribers, that is possible. So here multimedia files are retrieved. How do you retrieve? How do you fetch? So via HTTP protocol. It is a GET method is normally using. So that client has to be use the hypertext transfer protocol. I think you know that it is established the connection between TCP connection is established between that. So your requested client to the streaming servers via a communication network. So it is exactly, so there is a, so establish the connections. So here that is a, so this is exactly communication networks. The client is request the particular videos. It is exactly how do you request, so as and when the particular applications, so through the application of through the website, the hyperlinks are available. So as you request the particular audio or video through the hyperlinks, so the request will be passed on to the directly to the multimedia servers. So here it is exactly the multimedia servers. It is already audio and videos which are stored here. So multimedia files are retrieved via, so HTTP GET is the method. So the HTTP hypertext transfer protocol GET method. GET is nothing but we can able to fetch the particular files from the audios and video servers. That is also called as a multimedia servers. So here multimedia servers will send at the maximum possible rate. So here possible rate is nothing but always it is a, so whatever the encoded rate, that is the maximum possible rate means, so constant bit rate only it is sending. So it is what is the encoded rate? It is always it is equal to the maximum the constant possible rate. So that should be a constant bit rate, encoded rate. So assume that it is a encoded so any videos 30 frames per second. So example, so that encoded rate only, that is a constant bit rate. That rate only, the constant bit rate only send via, that is a TCP send buffer, it is available. So it is, you see that so 30% of the, so 50% of the, so buffers it is a built, so TCP buffers. So first video files which are already stored here, it is a storing of audios and videos in the streaming server. These video files are streaming so to the TCP. So that is a, so sender side also there is a buffer is available. Who is the sender? It is a multimedia server or streaming server is a sender here. So send via, so that is a communication network. So it is an internet environment. So this is a communication network. So there is a so many routers and so many internet service providers through which exactly your so audio or video files is passes through it. So here it is in the communication networks, delays are guarantees and jitter is a guarantee. So due to jitter, there is a variable rate of arrival of packets. Your audio or video packet is arrived to the client side. So client side, the receiver buffer it is also available in the client side. So this receiver buffer it is also a variable bit rate it is available. That is a x of t. You called as x of t. This is the variable bit rate. So this receivers receives the TCP receiver receives the packet. Even receiver, so initial buffering has been done. So initially that is a buffer it is a full. So that is at least 50% without any. So before play out the particular audio and video, so by the initial buffer, the client side, that is the application itself, So even TCP buffer is also available. TCP, it is a receiver buffer. It is a fills. You see that it is a fills the audio or video packets here. So assume that it is a video files which are streamed from the streaming server. It is a video files which are already TCP receiver buffer. It is almost filled. So 90% of the packets. Again, it is a playout from the TCP receiver buffer. It is just exactly, it is a send the TCP receiver buffer to the application. So it is exactly player as an application, even player also a buffer. So that's at least initial part of the, so that is a buffer has been filled, and rest of the parts has been so in the receiver side buffer will be sent out at some so even variable rate. It is exactly filled a maximum level. It is exactly filled at least 30 to 50% of the your application. So buffer, it is a field. So that constant player bit rate, it is exactly sent out to the for the playout of the video. It is possible. So that is exactly in the client side. So requested clients will be get back and also play out with the constant bit rate. That is the rate at which. So here fill rate is fluctuates. For example, this fill rate is fluctuates. So due to TCP congestion. So due to, so normally it is even for transmission control protocol. So congestion is guaranteed. Is due to congestions can be avoided by these congestion. So congestion control algorithms are available. So many congestion control algorithms are available that has been avoided. That is a congestion controls. So suppose if there is any, so that is a packet which are not received. Packet is so sequence number is available. Whichever the packet is not received, so that is a TCP can identify very easily, and it is a so in order delivery of the packets. Suppose if it is not orderly, it is a deliver the packets. So that should be so making by the so reassembly of the packets. So because it is already audio and video packet has been, so fragmentation has been taken place. If it is a so much of audio, so that is a packets. If it is a maximum size, so if it is a more than 20 or 30 MB packet, it is divided into smaller fragments. It is a so smaller audio or video packet. It is a even sequence numbers are added for so divided packets. So if it is a not orderly arrived, reassembly of the packet has been done here, and it is a so that is what we call a reassembly. So this retransmission, if it is any lost packet, suppose if it is a packet number third is not arrived, packet number fourth is not arrived, so it is going to tell by the TCP protocol. So it is due to retransmit the same packet again by the so multimedia server or streaming server. So it is in order delivery, it is occurs. One also in order delivery of the packet is occurs. So larger payout delay. Suppose if it is any larger payout delay, suppose if it is a so packet is not not all arrived from 2-3 seconds. So larger payout delays occurs. So that should be initial parts already it is available in the so TCP receiver buffer, smooth TCP delivery rate. So that definitely it is a so whatever already it is a filled so in the buffers that has been sent to the so application buffers. So you see that so application buffer also has been 30 to 50% has been filled. It is a so playout is possible without any so flickering in the images. So definitely playout is possible. So here. So the HTTP and TCP, so HTTP Hypertext Transfer Protocol or Transmission Control Protocol TCP, it is a passes more easily through firewalls because so cannot restrict the firewall. Firewall is a packet filtering device. Suppose if it is a so receiver side, it is a firewall. It is placed as a device like so. It is a each and every packet has been so it is a examines so whether it is allow the packet or reject the packets. So because every standard protocols like HTTP and TCP protocol send its own type of packets. HTTP packets like TCP packets like these kind of HTTP packets and TCP. It is a service oriented so packets. These packet cannot be restricted by your firewalls because already firewall rules has been set by the system admin or configuring who is configuring the so particular that is a client side once it is configured in that particular device. So firewall rules has been set. Any standard protocols like HTTP or TCP, this is exactly HTTP protocol. We are requesting the particular so okay hyperlink. So that is it is exactly so web servers or streaming servers. So the request so particular website. So through this HTTP protocol only, HTTP request will be passed on to that. So HTTP request will be sent by the client machine, and HTTP servers. So it is HTTP, it is a request and a reply. Reply will be get back from the media servers, or it is a video servers. Okay, so that is TCP connection. It is definitely, it is a TCP buffer. It is a sender buffer, receiver buffer is available to establish the TCP connection only. So that is a video server, audio servers has been connected, and it is send the audio or video packets to the requested clients. So it is a, it is cannot be, it is a more orientedly. So the HTTP and TCP, it is a service oriented packets, may not be restricted by your firewalls. Okay. So streaming the multimedia. So what is that? We learn about what is the Dash. Dash is nothing but it is a dynamic adaptive streaming over hypertext transfer protocol, HTTP. So here it is a multimedia servers, as you know that. So it is a contains the audio and video files. So if it is a file server, it is a divided into video files into multiple chunks, multiple packets. Chunks are nothing but it is a so many packets. If it is a packets are already, it is divided into so many chunks or so many packets. So each chunk are stored in the multimedia servers, or it is a streaming server. It is encoded at different rates also. I think it is a, so whatever the encoded rate is also ascending rate. So that's encoded at even different rates. If it is a quality of videos, if it is a high definition quality, encoding rate is differs. If it is a medium quality, is encoding rate, normal quality encoding rate is differs. So that so whatever the encoding rate you are expecting, so that rate you can able to request the audio or video files so over the multimedia servers. So that is encoding rate should be always constant bit rate only. It is whatever encoded rate, that rate only it is sent as a constant bit rate. So as and when the videos are requested by the any client. So here, so what is a manifest file? Manifest file is nothing but, so it is a provide the entire URL, uniform resource locator, for the different chunks. So it is a different chunks. It is where exactly it is available. So which directory, which videos, which video file, and whether it is audio file, it is available entire. So URL will be provided by the for the entire different chunks. It is suppose it is encoded with different rates. So in this URL, it is so you are requested so high definition. Okay, so encoded rate of videos which are available. Videos chunks are nothing but videos, which videos are different divided into so multiple chunks. These videos are available. That is the manifested file. Manifested file. So it is a complete URL about different encoding rate of so videos or audios. So it should be contained in the manifested file. Manifest file. So that is regarding the multimedia server or streaming server. So this is exactly the information. So here, so it is a client side. In the client side, the client is nothing but is the receivers. Receivers always periodically measure what is exactly server to client bandwidth. So what is the, so as and when requesting the audio and video, so it is a streamed out. So audio and video you are requested file to the requested client by the streaming servers. So periodically it is we can possible to measure that what is exactly server to client, what is exactly bandwidth is available. If it is a bandwidth is so less, it is exactly the condition is guaranteed. So you are so cannot able to play out so audio and video without so any, so that is a loss. So there is exactly, so your congestion is so due to a communication delays. If it is a so communication delays is common, it is an obvious over the communication works because it is a, so each and every route has processing delays, queuing delays, normally it is occurs. So that is the reason it is a, so even constant bit rate of sent by the streaming server or communication, so there is a multimedia server. So your communication delays, due to communication delays, there is a invariations in arrival of packets to the receivers. So what is exactly the bandwidth is available? If it is a bandwidth is good, your so invariation in arrival of packets can be overcome. So that's so that is the reason. So measure the server to bandwidth, the client bandwidth. What is exactly the bandwidth is available? Bandwidth is very very important. So if it is a so good bandwidth, we can even high definition videos, high definition encoded videos, so can able to download very easily, or we can watch out as a live streaming. It is from the streaming server to the requested clients is very easy. And consulting the manifest file. So exactly the client will always consult the manifest file. So that is gives by the streaming servers and request one chunk at a time. So assume that it is the client is request one chunk at a time. So choose the maximum coding rate. So what is exactly maximum coding rate? It is nothing but it is a So what is the encoded rates? So for example, 30 frames per second it is encoding, so that is a video encoded rate. So that is the maximum rate it is exactly sent by the, so that is a streaming server or multimedia server. That is the maximum sending rate. That is a constant bit rate. That is also called as a constant bit rate. So coding rate itself is the, so 30 frames per second of, for example 60 frames per second it is a, so it is a encoded rate. So that rate only is a maximum rate it is sent by the streaming server, it is a multimedia servers. So that rate is sustainable given to the current bandwidth, and also that rate it is always, it is a sustained. So what is exactly the bandwidth is available, that exactly seen, so by the exactly that is a streaming server, that is exactly a current bandwidth is what is exactly. If it is a current bandwidth is not good, so that is exactly, so it is not just the, so maximum, so maximum what is the possible rate. So it is always the current bandwidth that's also choose, and it is a maximum coding rate, it is exactly, it is assigned by the streaming server. It should be sustained to the, so that the bandwidth has to be sustained accordingly. So can choose the different coding rates also at that time. So suppose if it is a bandwidth is not sustained, so not that is enough bandwidth is available to download the particular videos. So suppose high definition rates of videos cannot able to download, so at the particular current bandwidth, so you have to different coding rates. So encoding rates of videos has to be download. Normal encoding rate of videos has to be download. So at the different points in time, depending upon the available bandwidth. So what is the available bandwidth at the particular time? So it is available accordingly. We have to pay. So download or streaming the particular so videos, so at the different points in time. So we can choose the different kind of videos. So suppose if it is a current bandwidth is not good, so that is available. So we can go for normal video. So if it is a bandwidth is good, we can able to so stream, you can able to download. So that is a high definition videos also. So what is exactly we learned from this dynamic adaptive streaming over HTTP? It is a very intelligence. Why it is a very intelligent at the client side? It is a determines adaptive. Adaptive is nothing but dynamically it is adaptable. So streaming rate. So over HTTP protocol when we use, so adaptable when to the request checks, when the user has been requested check, so that the buffer starvation may not be occurs. So because our overflow, buffer overflow, this does not occur. So at the client side, so it is related to the client side. How it is a client? So normally it is a client side. It is a buffer. It is available. Buffer it is available in the so player. It is available. So an application itself, it is a buffer. It is already acquired. So when the request a particular chunk, it is nothing but it is audio or video packet. So buffer starvation may be occurred. A buffer should not be drained out. It is a starvation means it is a buffer may not be drained out, and the overflow may not be occurred. Otherwise we cannot buffer it is a overflow, so buffer it is drained, so we cannot able to so constant bitrate rate so for sending by the a client side buffer to the play out the particular video, it is not possible. So when encoding rate is to the to request, so what is that? Higher quality when more bandwidth is available, we can high definition quality of videos. So high definition quality is nothing but 720 or 1024 so pixels into so some so horizontal vertical lines of pixels which are exactly it is so recorded. So that encoding rate of our request, so even we are bandwidth should be so more bandwidth is expecting, because it is a more bandwidth is available, we can able to so that is encoding, that is we can able to stream the encoded high definition quality of videos can also be streamed from the so streaming server to the requested clients. So what encoding rate? So otherwise it is a normal rate. So what encoding rate it is exactly request. So request to the particular client. So that is also so next. So if it is a streaming rate is so your current available bandwidth is good. So we can request. So the client can request. So can so higher so that is high definition videos also. So where to request the chunks? So where to request the chunks is nothing but so your streaming server is provide the so manifest file. So you can request from the URL server. So exactly streaming server will use the URL, uniform resource locator. These chunks are available. So it is that is very close to the, and also which server you may contact. So what is the name of the server? What is the name of the websites? That is a website with the servers, with the videos. So entire URL is nothing but complete. So the path is provided as a URL like uniform resource locator, like to the requested client, very close to so that server information, website information with the videos information, everything will be brought to the client, or as to the higher available bandwidth is available, you can able to download from the even high definition quality of videos. So that has to be so given by the streaming servers to the each and every requested client. That is the reason it is a dynamic adaptive streaming or HTTP protocol. So it is a provide the so to the client so these things, when to request the chunks, what encoding rate to request each of the clients, and where to request the particular chunks. So that information is provided by so dynamic dash protocol, dynamic adaptive streaming or HTTP. So protocols, once it is connected through this is multimedia servers or streaming servers. So over the dash protocol, definitely these benefit will be get back to the so each and every clients, when to request the chunks, what encoding rate to request. So we can request, so the client can request, where to request the chunk. So this information is provided by the dash protocols. So once it is this through which it is connected by each of the client, so to the multimedia server, this is possible. So in this class we have learned so adaptive streaming and dash protocol, and detail about dash protocols we have learned. So that's all about dash.